Hello everyone, I'm Mohammad Ali. So for today lab virtual experiment, we're going to do Coulombs law. So let's move on to the introduction. Coulombs law states that when 2 point charges Q1 and Q2 are separated by a distance r from each other, the magnitude of electrostatic force F and K is the proportionality constant, specifically known as Coulombs law constant, and is equal to 8.988 exponent 9 Newton meter square over c square, thus giving the final units of n. This particular virtual laboratory experiment uses a special simulation. The distance between the centers of the two spheres is measured by the means of the ruler in the simulation as the spheres are brought closer together or farther away from each other. When an identical positive charge is given to both spheres from the laws of physics, we would expect the charges to repel each other. The objectives for this experiment are to determine the value of Coulomb's constant K, compare K obtained with the theoretical value K, to determine the attractive force between the two charges, and to determine the repulsive force between the two charges. So let's move on to objective 1.
Yeah, my name is Hafiza. So I'm going to talk about the procedure for objective 1 and objective 2. So first of all, we have to click on the Coulombs law simulator and click macroscale. And then we set charge 1 to 1 microcoulomb and set charge 2 to 1 microcoulomb. And after that, we set the separation for charge 1 to 0 centimeter and charge 2 to 10 centimeter. Then record the force value in data table 1. Then after that, we repeat the step 1 until 4 with the different separation. And lastly, we record our values in the table given.
Hello,
Okay, we
my
move.
name is Wan Ahmad Azeem bin Wan Azizi. So right now, I will present the result from table 1 in objective 1. So from table 1, R2 value are 10 centimeter, 8 centimeter, 6 centimeter, 4 centimeter, and 2 centimeter. So the value for R2 in meter will be 0.1 meter, 0.08 meter, 0.06 meter, 0.04 meter, and 0.02 meter. For the third part in result from objective 1, we need to set the separation from for charge 2 from charge 1 from 10 centimeter, 8 centimeter, 6 centimeter, 4 centimeter, and 2 centimeter, which are represented as R2. So the force value that we acquired when the separation between charge 2 and charge 1 is 10 centimeter is 8.99 to the exponent negative 1 Newton. So next, the force value that we acquired when the separation between charge 2 and charge 1 is 8 centimeter will be 1.4 Newton. Next, the force that we acquired when the separation between charge 1 and charge 2 is 6 centimeter. The force will be 2.5 Newton. And when the separation between charge 2 and charge 1 is 4 centimeter, the force will be 5.62 Newton. And the last one, when the separation between charge 2 and charge 1 is 2 centimeter, the value for the force will be 225 Newton. So for the last part in the table objective 1, we simply need to use the formula 1 over r2 square to find the value. So the first one for 10 centimeter, the value will be 100 meter square. For 8 centimeter, the value is 156.25. The third one for 6 centimeter, the value is 277.77. For 4 centimeter, the value is 625. And the last one for 2 centimeter, the value is 2500. And for the last part in objective 1 result, we need to add the graph force versus 1 over r square to find the value of Coulomb's constant K. In objective 2, we simply need to use the data from result in objective 1 to determine the percentage of error by using the formula experimental value minus accepted value over accepted value times 100%. So in this objective 2, the experimental value will be 8.988 times 10 to the exponent 9 Newton meter square over Coulomb square, which is in this term K. And the accepted value, we can determine the accepted value from the formula F equal to K Q1 Q2 over C squared from the Coulomb law. That's all from me. Thank you.
Okay, hi, my name is Nur Maisarah Aida. Um, I will talk about the procedure for objective 3 and 4. First, click on the Coulombs law simulator and click the macro scale. Then, set charge 1 to negative 10 microcoulomb and set charge 2 to 10 microcoulomb. Then, set the separation for charge 1 to 3 cm and charge 2 to 10 cm. Record the force value in data table 2. Then read the experiment. Step 1 until 4 was repeated with the different value of charge 1 and charge 2 and the separation distance between two charge R.
Hello, my name is Alysheron and I will explain about the result for objective 3 and objective 4. So, for the first part of the experiment, the charge 1 is set to 10 microcoulomb and located at 3 centimeter, and charge 2 is set to negative 10 microcoulomb and located to 7 centimeter. So the force of charge 1 on charge 2 is 5.62 times 10 exponent 2 Newton, and same goes to the force of charge 2 on 1. And based on this simulation, the force is attracted to each other. Okay, for the second experiment, the charge 1 is set to 8 microcoulomb and located at 1 centimeter, and charge 2 is set to negative 7 microcoulomb and located at 9 centimeter. Okay, so the force of charge 1 on charge 2 is 7.86 times 10 exponent 1 Newton, and same goes to the force of charge 2 on charge 1. So from this simulation, the force is attracted to each other. Okay, for the third experiment, charge 1 is set to negative 10 microcoulomb and located at 1 centimeter. Then charge 2 is set to 5 microcoulomb and located at 9 centimeter. Okay, so the force of charge 1 on 2 is 7.02 times 10 exponent 1 Newton, and same goes to the force of just 2 on 1. So the force is still attracted to each other. Okay, for the fourth experiment, the charge 1 is set to negative 5 microcoulomb and located at 1 centimeter. Charge 2 is set to positive 5 microcoulomb and located at 9 centimeter. Okay, so the force of just 1 on 2 is 3.51 times 10 exponent 1 Newton, and same goes to the force of just 2 on 1. So the force is still attracted to each other. Guess for the sixth experiment, just 1 is set to 9 microcoulomb, located at 3 centimeter, and just 2 is set to 7 microcoulomb and located at 6 centimeter. Okay, so the force of charge 1 on 2 is 6.29 times 10 exponent 2 Newton, and same goes to the force of charge 2 on 1. So based on the simulation, the force is repelled to each other. Okay, next, the charge 1 is set to 6 microcoulomb and located at 1 centimeter. Charge 2 is set to 10 microcoulomb and located at 3 centimeter. Okay, so the force of charge 1 on charge 2 is 1.35 times 10 exponent 3 Newton, and same goes to the force of charge 2 on 1. So from the simulation, the force is repelling to each other. Okay, next, charge 1 is set to negative 2 microcoulomb and located at 2 centimeter. Charge 2 is set to negative 8 microcoulomb and located at 5 centimeter. Okay, so the force of charge 1 on charge 2 is 1.60 times 10 exponent 2 Newton, and same goes to the force of 2 on 1. So the force is still repelling to each other. Okay, the last experiment, charge 1 is set to negative 10 and located at 2 centimeter, and then charge 2 is set to negative 7 microcoulomb at 4 centimeter. Okay, so the force of charge 1 on charge 2 is 1.57 times 10 exponent 2 Newton, and from the simulation, the force is repelling to each other. So that's all for the result for objective 3 and objective 4. We proceed to the conclusion.
So for the conclusion, in this experiment, we were able to observe and compare the experimental and theoretical values of Coulomb's constant K, and that the electrostatic force between the two charged pairs is proportionally dependent on the product of the two charges, as well as inversely proportional dependent on the squared separation distance between the two charges. Also, we could determine whether the force between the two charges is attractive force or repulsive force. So that is all from us. Thank you.